Now, with exponential graphs, so an exponential, if you remember the term exponent means power. So power or index. So if we remember our terminology, this gives us an idea of what type of graph we're talking about for an exponential. And that would be one where we have an x in the power. So something like 2 to the power of x. So really it can be any number to the power of x there. But all these graphs have very common features. So first thing we want to notice, when x is equal to 0, what do you notice? Anything to the power of 0 would be 1, no matter what a is. A is just some number. But so it could be 10, could be 2, could be million. Anything to the power of 0 will go through the y-axis at 1. So we're going to get this common point of 0, 1 there. So what happens as x approaches infinity though as well? A to the power of infinity gets really large. So as x gets larger, y gets larger as well, and gets large pretty quickly. But what about negative infinity? So if we've got a to the power of negative infinity, well, that would be a case where if we've got a negative power, we start to write that as a fraction. So if you remember that, remember our index laws there, we get 1 over a to the power of infinity. Now, 1 over a to the power of infinity, well, as we said, a to the power of infinity starts to get really large. So we get a fraction that's 1 over infinity there, and 1 over infinity will be really small. So as x approaches negative infinity, we get y approaching 0. So the y values are going to be 0. No, remember, we're going to have an asymptote because a to the power of x cannot be equal to a negative value. It can't even be equal to 0. You can't take a positive number, put it to the power of something, and get a value that's 0. It won't happen. There's no value of x that will do that. So it's going to have an asymptote on the y-axis, and it's only x value can go in, but we will only get positive y values. So graphing that idea goes through 1. As x gets larger, y gets larger. It gets large pretty quickly. And then as x approaches negative infinity, y would approach 0. And see my graph here, because I've done it with a graphing program, it starts to have trouble to distinguish between the x-axis and the graph itself, because it's just the gap's so small. And you notice it gets small really quickly as well. So again, that would depend on the value of a, but that's generally how they will all go. So as you start to see, graph of y equals 3 to the power of x, again goes through 1, goes through and approaches negative infinity. When x is equal to 1, we get probably most distinguished feature is 3 there. So because x is 1, y would be 3. Anything that's different about this is the scale. So x is 1, y is 5, because it goes through 0.01, it gets really large really quickly, and it approaches 0 really quickly when we go to negative infinity. So it's the same shape every time. 10 to the power of x, again, it gets really large really quickly. Our scale isn't handling it even there, because when x is equal to 1, y would be 10, so it's going to be up there really quickly. And again, the larger the number, the quicker it approaches infinity, but also the quicker it approaches 0 as it approaches negative infinity. Now hopefully you notice the difference between this one, 2 to the power of negative x. So what does this mean? Basically, you're going the opposite way. So putting a negative x there really is just swapping the x and y values around, positive and negative x values around. So if you put all the positive values in there now, that would become negative. So 2 to the power of negative, and we said once it's negative, we approach 0 because it becomes a fraction. Where this one now, when we put the negative values in, the negative times the negative values make them positive, so they start to approach positive infinity that way. So that's the only difference a negative power, a negative indice up there would make. That would change and swap the x and the positive and negative x values over, so the curve gets reflected. So if we drew 2 to the power of x up, it would look the same, except it would be graphed in the other direction. A negative in front here, Well, what does that do? Well, that starts to take 3 to the power of x, which would look like we had before, and would take all the values of the y though and make them negative. So a negative in front will reflect it in the x-axis, and that's going to happen if you take negative of any function. If you can graph the function and put a negative in front, it just turns all the positive values into a negative value, and then we can graph all our y values there. So that's all the difference is. Now we include this one at this time. Now E, you might have seen in your calculator, we're going to do a whole lot of work in the HSC course on E, exponential. Now this is a value that's an irrational value, and it's about 2.7128. Then it keeps going on. It's like pi, it's irrational. It doesn't have an exact value. But we do have a lot of work we need to do with it, and as I said, we'll do it in Year 12 in the HSC course. We'll work a lot with exponential functions and log functions and their derivatives, and working with calculus with these, because it has a special place once we start to apply calculus to it. But we include it there, and it's just about 2.71828. So you can get all these values. So you can see, so we can see that when x is equal to 1, it's starting to get up there. Between 2 and 3, so that value is there. You can find that, see that value on your calculator. So because you've got the e to the power of x button, so put e to the power of 1, that will give you your exponential value. So there's how we graph an exponential function. Again, look for the key features: going through 1, going as x approaches infinity, y approaches infinity, as x approaches negative infinity, y approaches 0, and then have a look at the other things we can do. Put it to a negative power or put a negative in front, and what changes does that have on the curve? The curve stays the basic shape, it'll just do a few different things. So we can realize what that needs to happen. We can draw up an exponential curve anytime.